Howdy, everybody. Last week we talked about adding holes to our CAD. And when I was watching those two videos, I realized I made a couple of mistakes, very minor, but it's a great teaching example of why you would want to make something fully parametric. So it's easy to go back and correct something or make a small change if you need to. So last week, when creating the magnet holes, I needed to be sure to set this diameter to 6.5 millimeters. And I'm going to go ahead and double click this now and open it up. So we have 6.5 millimeters there. It's good. And where this says angled, you see how there's a taper on the inside. I don't actually want that. I want to make it flat. And I'm going to have to do this for both magnet holes and screw holes. The diameter is fine on screw holes, but I need to make that flat. And I made a mistake on this dimension. I was saying 4.8, but I actually input 4.5. So I'm going to fix that. Four point eight and 4.8. Now, changing this one dimension here and one dimension here should update both magnet and screw holes. And I'm going to double check on screw holes that it updated. And it did. So that's why you should reference measurements and constraints that rely on each other, because if you change one, then they all change. It just makes your life easier when you need to make a small change to a CAD. That being said, for this episode, I'm going to have to spoil the ending just a little bit, but I think you're going to be okay with that once you do see the ending. So our end goal here is going to be to pattern this shape in both our x-axis right here, x positive axis specifically, and our y positive axis, which is why way back in episode 1, we have our y units and our x units. So I'm going to go back and I'm going to hide all these planes. But just keep that in mind when I create this next sketch. So right now, we're going to create a sketch on this face. And we're not only going to make it one height unit, but we're also going to make the stacking lip as well. And next week, we're going to actually detail our stacking lip with this geometry mentioned here on the drawing. So I'm going to start by creating reference geometry. This edge, and this edge. And this week is going to be the first time that I don't use a centered rectangle. I want to use a rounded rectangle. So what that lets you do is click one corner, drag to the next corner, and now you get to automatically add fillets. So it's pretty nice when you're wanting to save some time. And what I'm going to do is I'm going to create a coincident constraint for this point on that edge and this point on the left edge. Now I need to constrain this diameter to be global variables and fillet diameter 3. And now, as you can see, every fillet was updated. And next, what we'll need to do is use our smart dimensioning tool like I said before, I'm going to spoil the ending a little bit. Now, we still have a ways to go before we get there, but I'm going to go ahead and do the geometry to make this all work in the end. So what that means is I'm going to do some linear algebra. And with the way I have to type all this out, it might seem a little complicated, but it's actually quite simple. So our first grid square here has a length of 41.5 millimeters. What we need to add to that is, if we want to multiply this by our pitch to recreate more units later on, I'm going to need to reference our pitch right there. So this is giving me the final result, but basically that's 41.5 millimeters plus 42 millimeters, which you can do the math, and that's going to be 83.5. Now, that's the slope of our line, if you will. And we want to multiply that by our x units, because again, this is our x-axis. So x units. However, if we do that, then the length of this line is 83.5 millimeters, but we don't want that line to be that. We want it to be 41.5 millimeters. So we have to add in is -1. And there you have it, 41.5 millimeters. Actually, I shouldn't have said the length of the line. It's the length between these 2 points. And that matches up right there. So I'm sure you guessed it, but next we're going to be doing this in the y direction. So it's going to be the same equation, 41.5 at a unit plus the slope of our line, which is pitch. We're going to multiply that by variables object, except this time we want our y units. And remember to subtract 1. So 41.5 millimeters there. And click OK. I'm going to resize the window. As you can see, we're fully constrained, which leads us to sketch 7. So I'm going to rename this. I can find it in the menu. I couldn't, so I'm just going to do it this way. And I'm going to call this our box outline. And because I'm adding material to create this height unit of 7 millimeters here, I want a pad. But I want this pad to be parametric as well, because I don't know how many height units I want for my Gridfinity box, which means I need to do some linear algebra again. And that is, I need to reference our global variables, but this time I want to reference height pitch of 7 millimeters, but I'm not done there because I need to reference my global variables again. And this time I need to reference height units, which is still 7 millimeters now, because if you remember from episode 1, we have 1 height unit set currently. And like I said previously, I'm not just going to make this 1 height unit, because as you can see here, that little grayed out area is our stacking lip on top of the height unit. So what I'm going to do is I'm going to add this 4.4 millimeters to my one height unit, which that 4.4 millimeters is 0.7 plus 1.8 plus 1.9, which is actually just our profile offsets. So what I'm going to do is I'm going to add the profile offsets variables that we made in the first episode. So there's plus profile offset 1, and here's profile offset 2, and here is profile offset 3, which is 11.75 millimeters. And basically what this is saying is that you have your first height unit here plus another height unit, which is going to be 2 height units, and all that in total is 18.4 millimeters. So if we subtract that, doesn't really matter. I was going to try to do some math here, but I know this is correct. So there's our pad, as you can see, with our 4.4 stacking millimeters accounted for, as well as another height unit. And I'm going to rename this pad box volume. Now, I said I was spoiling the ending, so I am going to do that just a little bit. I'm going to give this 5x units. Now, granted, the rest of this won't be as parametric or patterned as it will in the end, so it's only a half spoiler. But I want you to watch what happens to the x-axis of this box volume. You see how it extends itself? Well, just for funsies, let's add 3 in the y units, and then extended itself again. So this is the value of parametric modeling, which is that you can set things up based on variables, and everything in your model will change relative to these variables. It'll make CADing repetitive patterns much easier for whatever it is that you're wanting to do. So like and subscribe for more, especially if you enjoyed this video. Next week, we're going to be actually making the stacking lip on top of this. And I hope to see you next week. Have a great week.